Yeah, hello class. This is the video for section 8.3, testing a claim about the mean. Now, at the end of this, we should be able to test the claim about the mean when the sigma is known, and then when sigma is not known. If it is known, we use the what? The normal distribution. If it's not known, we use the t distribution or a z statistic and t statistics respectively. Now, let's take example where we will use what the statistics when sigma or the population standard deviation is given. Okay, so let me change my color. All right, now either you use the p-value method or the critical value method, right? You arrive at the same conclusions. All right, so in the examples that we'll be looking at, I will try and use both of them. By the point, I will just switch to either one or the other, maybe the p-value approach, okay, or method. Now, here's a claim that the smartphone carriers data speeds at what airport, with a mean that this is what a left tail test. So for any test, we do the what? We write the steps down. Your null and the alternative hypothesis. So let's do the p-value method, okay, and then we do the critical value also. Now, step one, what is my HO? That is mu is equal to 12 versus the alternative, which is mu is less than what? 12. This is a left tail. As a left tail test. Step two, what's my sigma? What's my alpha? According to the question, the alpha is what? 0.005. And what's my test statistic is given here? Okay, which is z is equal to negative 2.548. Now, step four is to calculate the p-value. A p-value is a probability that my z is less than or equal to negative 2.58. Now, remember, this value is from where? P-value depends on the test statistic. Now, I can get it from my StatCrunch or the table. So let's switch to StatCrunch. Okay. Now, to find that value or the p-value, go to statistics and then calculators and go to normal distribution. Now, we want to find the probability. It's a left tail to the left. So this value should be minus 2.58. So that's the probability. That probability is 0.0049. Okay. So when we go back to our problem, then the p-value in this case is what? 0.0049. Okay, step 5, what is our decision? Now, p-value 0.0049 is less than the alpha value, which is 0.05. Okay, and so in this case, we reject what? Reject it. Okay, now I can do the same thing using repeat this solution using the critical value. Okay, so I'm going to do that, but remember the first 3 steps are the same. So I'm just going to use critical value, and then I will erase this part and calculate the critical value, and then compare and see if we can arrive at the same conclusion. Okay. Okay, so we just erase that. Let's pick our pen. Then we need to calculate the critical value approach or method, right? Critical value approach or method. We need to find the critical value. Okay, our alpha is 0.05. All right, so if I draw the density curve, it's a left tail, right? It's a left tail. This probability should be 0.05 here. And I want to find this z value. That should be what? Negative. Okay. So I go to my start crunch and calculate that value. Or use a table. Okay. Here is it. But I want to find the probability to the left of, which is what? 0.05. What is my critical value to the left of that? Okay, let's compute that. That is what? Negative 1.645. So go back to our PowerPoint. Okay. So this value here, this value is what? Negative 1.645. So my critical value, which is what? C, 0.05 is equal to minus 1.6445. Okay, now what's my decision? Now, if the test statistic, is less or equal to critical value, because I left it, and then we reject HO. So in this case, we know that the test statistics were negative 2.58, and that is definitely less than what? Negative 6.45. And so we will reject HO, just like we use the p-value approach. Okay. So now we will switch to the t distribution, where the population standard deviation is not given or is not known. Okay. So when that happens, we use this what? This is the test statistic. Okay, that's a formula for that. And then we can use both what? T-values and the critical value. Now, whichever method you use, the degrees of freedom is still n-1. All right, n-1. In this case, in this example, like I said, I'll be using the start crunch instead of the table to calculate the critical value. If it's two-tail, that will be critical values. All right. So let's look at example. Repeat the same, the previous example, but this time we use the T. Okay. So I'm gonna, let me see if I have some space here. All right. What we know is this. Let me get it. What we know is this one. Let's see if we can. Okay. So let's start with the p-value method. Okay. Step one, what's my null hypothesis in this case? Now my null hypothesis was the equality. All right, so this is mu is equal to 12 versus the alternative. This is mu is not equal to 12. So this makes it what? A two-tail. This is what? A two-tail. Okay. The two-tail test. Now what's my sigma? Sorry, my alpha is 0.01. What's my test statistic? T is equal to negative 2.571. Okay, it's a two-tail, so p-value is calculated differently. Okay, there's a catch there. You have to be careful how to calculate that. And so p-value is going to be 2 times the probability that my t is less than or equal to the test statistics, 2.578. Okay, so because it's a two-tail, so this will be 2 times. So let's go to the t distribution and calculate this probability. All right, so I go back to my start crunch. Okay, I don't need this one. Now this time I use the t distribution. So start calculators and then t distribution. Okay, what's my degrees of freedom? It's 14 minus 1, so that's 13. Okay, what's my test statistic? test statistic is what? Negative 2.578. Okay, so we want to find a probability that it is less than this. So compute that, that is 0.00, so 0.115, 0.0115. So let's go back to our PowerPoint and put that value there. So this is actually times 0.0115. And if you multiply this by 2, you get 0.02 or 3. Now, what's our decision? P-value, in this case, which is 0.023. If it is less than or equal to alpha, in this case, it's less than or 0. It's actually greater than alpha. Okay, it is what greater than 0.01. And so here we do not reject HO. Okay, now if I use the critical value method, okay, I'm going to repeat that, but okay, step 4 and step 5 will be, step 4 in particular will be different. So because we need to calculate the critical value, and because this is a two-tail, we will need to have two critical values. Okay. All right. Now let us do the critical value method. Okay. So critical value method. Okay. Which is that one. These steps are the same. Now this time we calculate what? Critical values. Okay. Now alpha is 0.01. So in this case, we divide by 2, which is 0.005. So this is what is happening. Okay. This side is 0.005. This side is also 0.0015. So that when you add everything, you get what? And then the middle is 0.99. Okay. So we want to find these values here. That's why it's plus or minus. Okay. So we want to find T 0.005. T 0.005. So I go to my StatCrunch. Okay. And this time, I want this value in the here. I can do the greater than or less than, same degrees of freedom, but my probability is 0.0015. Okay, so compute that. That is negative 3.012. Okay, so let us go back and then enter that into. Okay, so the critical values are, in this case, will be what? Plus or minus 3.012. Okay, so let us decide. Go to the next step. Step 5 is this. That's our decision. Our decision is that. Okay, because the test statistics is negative, right? You have to compare it with your negative critical value. If test statistic is less than or equal to the critical value. Now, which critical value? The negative one, which is 3.012, and my test statistic is negative 2.578. This is what less than, and so in this case we reject H1. So we arrive at the same one, same conclusion. Same conclusion. All right. Now let's take other examples. This is a homework 2, and it comes with data. All right. So we're going to do it using p-value method and critical value method. But I'll start the process here. My n is what? N is 50. Okay. My alpha is what? 5%. And then what kind of test is that? It said that the mean magnitude is greater than what? Greater than 1.00. So this is the data that we're going to look at. And so I'm going to use that data set to do the same thing using StatCrunch. Okay, so let's go back, and now before that, let's set up the procedure. Step 1, alpha, let's write n is what? 50. So it means that degrees of freedom would be what? 49. So take note of that. Okay, and then we know that that's all we're given. But HO is what the mean is equal to 1.00 versus the alternative H1, and it says that it is greater, so greater than 1.00. Okay, so it's greater than 1.00. Now, what is my alpha? Alpha is 0.05. Okay, what's my test statistic? Okay, test statistic. Now, notice that this is what? This is with the data. If I'm using the StatCrunch, it's very important to know that. So what's my test statistic? Okay, we'll figure it out. Is a t equal to something, and then what's my p-value? We'll get that from StatCrunch, and then we'll decide step 5. Okay, so let's just go to let's go to the homework. Okay, let's go to the homework. Again, let me close this and share. I can almost get it. Let me go back. Share this. Okay, so homework is 8.3. Let's preview that. And that's that's question number 3. I'm going to share that in a minute. Okay, so let's share that with you now. That's supposed to be that. Okay, so it says that the accompanying data table lists the magnitude of 50 earthquakes measured on the Richter scale. Okay, test the claim that the population of earthquakes has a mean magnitude greater than what? Than 1.00. Alpha is 5%. So what we do is that we just stated the null and the alternative hypothesis. So I'm just going to open this and show you how to calculate the what in StatCrunch. So let's open this in StatCrunch. Okay, let's share that with you, which is right here. So we're going to go start. Now you don't go to calculators, you go to a T statistics, and this is one sample, but this is with data. So you select data, select that, and then we are doing what hypothesis test, where it is 1.00, and this is what greater than, it's a right tail test. Okay, it's greater than 1, and just say compute. So select your variable, specify your testing value, okay, your null hypothesis, and then what? Compute. Okay, now what is the p-value? P-value is 0.0154. My test statistic to 2 decimal places is what? 2.22. And so let's go back to our PowerPoint, okay, and then complete that. Oh, let's go back. So this is the test statistics is what? 2.22. The p-value was 0.0154. Okay, so to 4 decimal places, right? What's our decision? Well, what's our decision? The decision is that p-value 0.0154 is actually less than 0.05. So we reject what? HO. All right. So I need to use the p-value, the critical value method to arrive at the same conclusion. So let's go to the next slide. Okay, set up the procedure. HO mu is equal to 1.00, and then H1 is mu is greater than 1.000. 2, your alpha is the same, 0.05. 3, the critical value in this case we calculate is what? 2.22. And then 4, we need to find, sorry, test statistic, not critical value. So now we need to find a critical value. It is one tail, okay? Your alpha is 0.05. So we want to find Z 0.05. What is this value? And then we'll decide. Sorry, step 5. We'll decide. Sorry, you get some more. All right, so if we go to the StatCrunch, okay, let's go back to StatCrunch for the same, okay. What we need to do is that we're going to critical value. So that always you go to the calculators and then go to pick the T distribution, okay. What's the degrees of freedom in this case? The degrees of freedom is what? 49, because n minus 1. Okay. And then what's the probability? Is a right tail. Okay. So 0.005. Okay. And then want to find to the right. So that value is 1.677. Okay. So go back to our PowerPoint. Sorry, this is not a Z, it's a T. The T 0.05 is what? 1.677. Okay, what's our decision? What's our decision? Now, if it's a right tail test, if the test statistic is greater than or equal to the critical value, that's a positive of that, then we reject HO. And so our test statistic is what? 2.22. Of course, this is greater than 1.677. And so again, this case, we reject what? HO. Same decision that we arrive at using the p-value method. Let's take another example. So this is with summary data, all right? Like a homework question number 1. Here we are with summary data. My n sample size is what, 600. Sample standard mean is 5.36. Standard deviation is 4.61. Alpha is what, 0.01. And then I want to test the claim that the population mean is what, equal to. So remember, equal to meaning that my alternative will be what? A two-tail, not equal. So that's a two-tail test. Okay, so I'll use the p-value approach to get this same results. Okay, so now let's find a two-tail. I'm going to use this one. I'll do the p-value, only the p-value approach or method. So let's do p-value or method. Okay. So H1 is what? The mu is equal to 5.00. The alternative is what? H1 mu is not equal to 5.00. So that is why this is a two-tail. It's a two-tail test. All right. Now, what is my alpha? Alpha is what? 0.01. Okay. What's our test statistic? Okay. The test statistics was given in the question, was it? All right. Let's go and check. Okay. We don't know the test statistic wasn't given, and so means that we need to what? We need to go and calculate that using summary data from StatCrunch. Okay. So we need to get a test statistic, which is a t equal to something. Our 4 will be a p-value. Now, when we do that, these values will be given in the same output. So let's go back to StatCrunch. Okay, I'm going to close this. So I go to statistics and go to t-statistics, and then this time with what? Summary. Okay, my sample standard deviation is 5.36. Sample mean, sample standard deviation is 4.61, and then the sample size is what? 600. Okay, it's a p-value. It said that the null hypothesis is what? 5.00, and it's a two-tail. So by default, that is it. And then say compute. Now, when I compute, this gives me the p-value, which means that's already been multiplied by 2. So I don't multiply this p-value by 2. It's given. Okay, my test statistics is what? 1.91. Okay, 1.91. So we go back to our, and then PowerPoint. Okay. This is 1.91. The p-value is 0.0. Let's go back. It's 5. Was it 5? 0.056. Let me go back and check that, making sure I got that value right. Okay, yeah, 0.0562. So go back to our point. So this is 0.0562. Now, if you look at this, since p-value, okay, p-value is what? 0.0562 is greater than 0.01. This is my alpha, that's my p-value. We do not reject HO. We do not reject HO, meaning that we don't have sufficient evidence to reject or the HO or warrant the rejection of the null hypothesis or your claim. Okay, so the last example is this is with data. So it's a left tail. So let's see why that is a left tail. Again, I'll do the only the p-value, right? Okay, so here's the lead concentration in milligrams per gram, all right, microgram measured in different traditional medicines. Alpha is 5%. So you want to test the claim that the mean lead concentration for all such medicines is less than what? 14 μg per g. All right, so this is our data set. So I'm going to open StatCrunch, we enter these values, and then do the p-value. This is with data. Okay, so, but let us write down our null hypothesis for this. Okay, before we go there, the null hypothesis for mu is equal to what? 14. Okay, mu g per g versus alternative h1 is said to what? Less than, so that is mu is less than 14.0. Okay, mu g per what? Per g. All right, that is one. Step two, what's my alpha? 0.05. Step three, what's my t? We'll find that. And then step four, what's my p-value? We'll get that from the output, and then we'll decide. Okay. Step five, we'll decide. Okay. So now let's switch to StatCrunch. Okay. I'm going to call this lead concentrate, right? I'm going to enter these values there. The data set we have was 6.5, 13, 6, 9, 18, 5, 17, 12.5, 22.5, and then 3.5. Okay, let's see if I got everything there. Oh, I got double here. That's 13. Okay, I have 18 and everything, so I'm missing the 6. So I'm adding to that. Okay. So I have 6.5, 13 is there. I have 6, I have 9. I have 6 and 9. Making sure that we have everything. So 9 is 18. 5, 17. That is 9, 18. Okay. Then 5. And then 17. 12.5. And then we have 22.5. And then we have 3.5. Okay, making sure I have everything. I have 6.5, 13. I got 18 appears twice. So, okay. Let me just use a different column. 6.5, 13, 6, 9, 18, 5, and then 17, 17, 12.5, 22.5, and 3.5. Okay, so we have 6.5, 13, 6, 9, okay, 18, 5, 17, 12.5, 22, 3.5. Okay, so then I go to my statistics. I go to what? T statistics, one sample. This is with data. Okay, my variable is that, my column is the V3. And then I'm testing what? Okay, I'm testing this what is 14. So this is 14, that's 1, 4. And what's the alternative? Alternative is what? It's less than. Okay, so we're going to change this to what? Less than. So once we have that, okay, then we say compute. Okay, when we compute this, my p-value is 0.1062. Now test statistic is negative 1.34. Okay, so let's put everything in. We gotta share that, and we go back to part 1. Oh, let's go back. This is negative 1.34. I will have to check that value, 0.1062. Let me make sure that I got those correct. Okay, 34, I've got everything right. So what's our decision? Again, you see that the p-value, which is here, 0.1062, is actually greater than 0.05. And so here, do not reject HO. Okay. So that is it for this section. I hope this helpful. I'll see you in a minute for another one.